Alright, welcome to the lunchtime video. I've got some really good news to start off the video. I'm officially registered for the exam under a valid account, and I was only charged twice. The method that I thought would be used where I'm issued a voucher code and then I just use that to waive the fee when I register a second time. That is what happened. Unfortunately, this process of sorting out the registration took me about 2 days or longer, and in that time my slot for 11:20 was filled by somebody else, but I got a slot on 11:18, which is going to be fine for me to take off a Wednesday instead of a Friday. I kind of would have rather had that's going to be fine too. So yeah, there's really not a huge difference between taking off a Wednesday and taking off a Friday. Losing 2 days of study is a little bit less than ideal, but I've got to take the test at some point anyway, so that's why it's important to really focus and get moving on this, get as much study in as I possibly can. Now that I'm registered for the 18th instead of the 20th, I've got significantly less than a month to study. I've got a month, but 3 days less than a month. So those 3 days I could do a lot. Okay, so let's get into the weeds again, and make sure that that I'm prepared for the test. Yeah, I guess I'm not sure what else to say about that. Oh, yeah. One thing I wanted to say too is, one thing I was really concerned about is, because you need a account that is tied to a approved employer that you currently work for, I was really afraid that if something happened with my current situation, I would lose credibility for all my certs. I would use, it just wouldn't say that I had those certifications anymore, because that old account would no longer be valid. But you actually get two accounts when you register for the exam. You've got to create the Juniper account at juniper.net that is tied to an active employer. And then you get another account, it's called your Cert Manager ID account, your Cert Manager account. So you get a special ID for this account, and then within that account you can tie in a personal email such as Gmail, and that's the account where you manage credit for your credentials. So you have one account where you manage earning your credentials, scheduling the tests, that sort of things, and then you have another account where you manage having credit for the credentials that you earned, and that account can be tied to a private email that's not associated with an employer. Okay, so hopefully that's clear. Let me know in the comments if there are any more questions about that. So this is going to be the second video now. It's going to be on IPv6. The videos I did yesterday were on just the registration. Unfortunately, I'm going to need to, so it'd be nice if I kind of had this whole spiel belonging to that playlist. Maybe I can just make another one independent later. I might do that. I might do like a 2-minute update or something quick for that other playlist. But right now, we're going to keep moving. Time is of the essence to the umpteenth degree. I absolutely, right now it's all coming to a head. It's going to be a pass or fail situation, and 5 minutes of time could have meant the difference between 1 point and no points. So all right, so let's get moving. So we're gonna take apart this current topology by deleting this, and we'll move this down here. Okay, so now we've got a interface configured on router E and router D that don't have connections. So let's start by erasing that extra config. Okay, and I'll move this over like that. Okay, so let's erase that extra config. Yeah, and yesterday, unfortunately, I wasn't able to make a after-work video. Things were just too nuts for me. Oops. Okay, so yep, now we've got GE000 is down because I don't need that anymore. So let's use well, you know what? I can still use .3 because now we've got. I think I can. Let's take a look over here. I just want to be extra clear on that. Do the extra command, kind of like the extra pass in basketball, the hockey pass. Okay, so now this is down. So we've got okay, so what I'm gonna do is leave this one configured. And then I'm gonna, from D, remove 3.1, and then on C, I'm gonna pin up another link, and then I'll add 3.1 there. So let's start by adding the link. It's gonna be on G002, and it's gonna be the 000. Okay, and then let's remove the configuration from GE001 here. Okay, and now let's go on router C. We won't need to configure router E for anything. It's already configured. And let's add the configuration that was previously on GE001 on router D. We're going to add that to router C, port to GE002. Okay, so hopefully if I go to router B, we're going to still have that .3 network, and then we'll still have all the networks we had before, but it's going to be configured a little bit differently. Okay, so let's see if we've got .3. Alright, so unfortunately I don't see .3. Yeah, so it looks like we're not getting .3. There's some sort of issue with this reconfiguration here. So let's double check these three routers. Okay, so I'm unable to ping .2. I'm thinking that, oh, I am able to ping .2. Okay, well, let's take a look at it even closer. Oh, I see. So I forgot to add .3 to the appropriate protocols to RSVP, MPLS, and OSPF. It's a missing step. So let's complete that step, and it's going to be 002. Oh, it's going to be area. Okay, now we're going to commit and quit. Okay, so we've got .2 added to all of the protocols now. So if I go back to router B, we'll see it showing up in the routing table. Okay, so everything looks good to go for that. Now that I'm at router B, that's good news because router B is a PE. So let's print out the configuration on that and save it. Yeah, off to Notepad++, so it's easier to look at later. Okay, now that it's in Notepad++, let's pull up router D because we're going to need to reconfigure router D from a PE role, P role to a PE role. So let's look at the difference between a PE router and a P router. You can see there's quite a bit of a difference. A P router has barely any configuration at all. It's just meant to transit the traffic through it, so it doesn't need to do any special things like add it or remove it from a VPN or send it as BGP NLRI instead of as an actual routing update. So yeah, we're going to need to make a lot of changes. Let's get started. So we're going to do, so we're going to keep this GE000, but it's going to be a core link. So it is going to be added to everything just the same way as everything. Oh, one thing we can do though is we can get rid of GE001 from all of the protocols. That's the low-hanging fruit, real easy thing to start with. It'll make everything easier to read too. So let's do that right away. Make it easier. Okay, so now if I look at the candidate configuration, you can see it's much more stripped down now, and it just has the configuration for the core facing side. Let's work on the configuration for the customer facing side next. So we're going to need a second interface. Okay, we'll set a description. CE facing. Okay, and we'll set a IP address. We do a run show route. Okay, so I'm learning all of the routes on the other side of the network. We've got 1, 2, and 3, and then I believe 4 is going to be on this one itself. Oh, actually 2 is going to be on this one itself. So it looks like 4 is not in use. I guess I'm surprised by that. I thought 4 was here. Let's check that. Okay, yep, just as I thought, 4 is in use, so let's go with 5 on this interface. .1/30. Okay. Okay, and now this is going to be 2, 3, 4, 5. So, oh, this actually, let's see here. This is going to be .2. Yeah, so this is going to be .5 here. So I believe this, yeah, this is .4 already. So it's already got a loopback. Well, it doesn't already have one, but I kind of want to change that scheme because there are only 3 routers that require loopbacks, so I'd rather just number them 1, 2, and 3. Numbering them 2, 4, and 5 really is confusing. But that would require a lot of configuration change, so let's just start with the basics here and then go back and change the details once they are required. So, yep, this is going to need to belong to a autonomous system as well, because we're going to need to form an IBGP connection, so it's going to need to know which it belongs to. Okay, and then the protocol's label switch path is where it gets interesting, because we're going to need to form a full mesh. So I'll do that a little bit later. Right now I want to be doing yeah, so this is what I want to do now. And I'll be using static route. Okay, and that one, yep, that looks good, but this is .4. :2 looks fine. Yeah, so all of this configuration here looks fine. This configuration down here is going to be is going to require changes. We no longer need an export policy because we're just going to use a static route. And static route is not a protocol, it's not a dynamic routing protocol, it's just a static route, so it's going to be under routing options. Static route, and then we're going to go to 172.16.0.3 /32 through 172. Through 10.0.6.2, or is it .5, that one? Let's take a look. So show pipe display set pipe more. So it's going to be .5.2. Okay, so we're good to go on this because we're going to have a new IP address. Let's take a quick peek at router A, what the loopback is going to be, just so I'm sure I have the loopback correct. So let's do a show route. Yep, so we've got .1 is direct, .2 we're learning over RIP, and we're going to be learning a new one, .3 over RIP as well. Oops, I've got to include the next hop. Okay, so everything looks good enough to me. I'm going to pin up a Cisco to be my PE facing route because those boot up a lot faster. And then yeah, that'll just be a stripped down, nice and easy configuration. So let's apply that. So we're going to commit and quit this, and then we're going to pin up that Cisco. Okay, so hopefully this comes up nice and quick. Looks like it's still stopped. I guess I'll hit start again on it. There we go. Okay, so it's loading the image, but typically this takes a lot faster than it does for Juniper's. Okay, and I'm going to look at the correct config instead. I'm not going to look at the config for router B, which I've been modifying, and it might just throw me for a loop. So instead we're going to focus on the config for router D. Okay, I've got the config for router D posted here for reference. It looks like it's a bit shorter. Yeah, it looks like it's missing a few lines. And the reason for that is because it doesn't have the BGP yet. We're gonna wait on that and configure this side first. So int GI00, oops, interface GE or GI 0/0. Perfect. Okay, so now we'll need a IP address. It's going to be 10.0.5.2/30. Oh, Cisco requires it to be spelled out. Okay, no shut. We're also going to need a default route. Okay, and we're going to need a loopback address. Okay, and I think that's it. Let's take a look at the show run. Yeah, so that's going to be it. Let's try pinging across the wire. Perfect. And let's check router A and see if we've got a route to 172.16.0.3. Oh, so the thing is, we're not going to have that yet until we get the until we can exchange routes. So just the fact that we were able to ping across the wire, I think, is enough for me to move on to the next step, which is going to be configuring IBGP. So I'll use the router B reference for that. So I'm not going to need trace options quite yet, hopefully. I mean, it's probably a good idea to just have them on, but for now I'll leave them off, just for the interest of time. Okay, now here's where things get interesting. Because this is a full mesh, since this has to be a full mesh, I'm actually going to require an extra statement here. And not only am I going to require an extra statement here, I'm going to require an extra statement on routers B and routers E in order to build that full mesh. So I'll need to go back and do that. Before I do that though, I almost forgot that I will need my label switch path as well. And just like with the full mesh for BGP, the way you can think of this is as if it were a wire. So yeah, you're going to need configuration that specifies a full mesh, but you also need the physical wiring. So this is the physical wiring, so you need a full mesh for this as well as the IBGP configuration. Okay, so you can see, so actually it looks like I overwrote, yeah, so I'm going to need to make sure I've got unique names for these, otherwise I'll just overwrite them. Okay, so we're gonna make one that goes to router E. Let's just start with that one. So it's gonna be 2.168.0.5, but then we'll also need one that goes to router B. So we've got to remember the two statements, TO. Here we go, and then router B. Okay, and it's going to be dot, instead of dot 5, it's going to be dot 2. Okay, and then those other routers are going to need statements to dot 4. So let's take a look at what we got so far in the candidate configuration. Okay, so we've got our full mesh of neighbors, and we've got our full mesh of virtual wires. So everything looks good to me. Yeah, I can't think of anything else that would be missing. So let's go to those other routers and add the full mesh. And at that point, we should be able to ping that Cisco router from any of the other routers. So we're gonna have to open up router B and router E before we do that, and create that extra virtual wire, and then add it to the IBGP full mesh. Okay, and I forget which router this is. It's router D. Dot 4, okay. And then okay, so we're good to go. We've got a full mesh of virtual wires, and we've got a full mesh of IBGP neighbors. Alright, so we've got one more router to do that with. Now we did have options. We could have either built this full mesh, but this doesn't scale. Imagine we had 20 routers. I would have to go and do this process to all 20 of them, and it scales up exponentially. So it's, I think it scales up exponentially, but it scales up in a way so that you wouldn't want to have to sit down and enter it all manually. So I would recommend in that scenario using a route reflector. You can also use BGP route confederation, but I would rather use a route reflector. Actually, you can use either. I'd be okay with route confederation, but I think a route reflector is what is more commonly used. I should probably practice both, actually. Okay, so now we've got our full mesh of, oops, so it looks like I don't have a full mesh of physical wires. I'm missing the one to router D.4. Not sure what happened to that. Okay, so I fixed that. Let's check the neighbors. Oh, so it looks like I'm missing the neighbor to router D.4. So I guess I'm not sure. Let's do a show pipe compare to see what those other commands I entered were. Okay, so those, I thought I entered 2 commands. Maybe there was like a error or something that didn't get entered, but it looks like I'm good to go right now. So we'll do a commit and quit, and we can stay on router E, do a show route, and hopefully we've got that new loopback 172.16.0.3 address in the routing table. Now it's going to be in the VPN. Yeah, so I would expect it to show up here. Okay, so clearly there's some sort of issue. Ah, no there's not. So perfect, yep, we got the new one. It's there from router D through the label switch path, so everything is perfect. And you can see, yep, it comes in through the L3 VPN. So yeah, everything is perfect. Let's just do, just for satisfaction, because it feels good. From router F, let's ping 172.16.0.3 from the source of .2. Perfect, and now we can ping that extra endpoint. So you can see, nice and easy. It's really not anything too complicated. There's a lot of different flavors and variations for L3 VPNs, but basic, most simple one, I actually very nearly knew all the way from memory without even getting through the module. I did have to do a Google search, but it was just for that local address statement that I forgot to include. Okay, so this is meant to be for IPv6. So let's change the CEs so that they all ping each other with IPv6 now. Now the actual service provider topology is not going to need to be reconfigured. That's kind of the whole point, is how you can serve IPv6 customers with an IPv4 infrastructure. And the reason you can do that is because BGP passes NLRI, network layer reachability information. It just exchanges data. It doesn't exchange actual routes. So whether it's an IPv6 or IPv4 route doesn't matter, as long as you tell BGP which kind of information it is. You can do that on a more like abstract level instead of having to go and make major reconfiguration. You can just add the statement here, set protocols, BGP group, IBGP family, INET, and then it's going to be INET 6-VPN unicast, I believe. Okay, so let's start by reconfiguring all 3 of these routers. And these are going to be the 3 CE routers. We will need to make a change on the PE router as well, but it's just going to be to change which families are processed by IBGP. We can still have IPv4 addresses used to form the LSPs and used for the IGP, and even used for the route distinguisher and the physical addressing. Okay, so yeah, let's also go back and practice the CE/PE variations, and we'll do that by picking a different connection for each of these. So for this one, we'll use OSPF version 3. Here we'll use eBGP, and then here we'll use static. I'm tempted to use RIP because static is. But let's just do it that way. Okay, so we're gonna do. Let's see here. So show. Yeah, so now we're gonna have IPv6 connections to the PE. and we're going to be exchanging IPv6 loopbacks using IPv6 protocols. Okay, so let's go with the IPv6 address here now. INET6 family. Oh, yeah, family INET6 address. Yeah, there we go. So we'll go with 2008. Oh, I forget what the documentation was. One was. Let's just make it easy, and we'll do 1000. 1001 colon 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 1, or let's just do 1 colon colon, and then it's going to be an equivalent to a /30. So this side's going to be :1. Okay, and then it's going to be a /127, which is the equivalent to a /30. Okay, and then we'll do set interfaces 0.0.0, family INET6. Okay, and then we'll do something special for this one. Let's do 172 colon colon 1/128, and we'll just use that 172 so it's like more similar to the IPv4 loopbacks we were using. Okay, and then on this one we're going to use OSPF version 3. So let's set that up. So edit protocols, OSPF 3, area 0.0.0.0. Set. Now we won't need traffic engineering, anything like that, but let's do set interface. And then we gotta have the name of the interface, which is the one we just configured. Okay, so we've got everything looking good. I don't have traffic engineering enabled, but I don't even think you can enable it for OSPF 3, and it doesn't need to be enabled. So let's commit that and quit, and then open up the PE and try to get that OSPF neighborship to come up. Okay, so the configuration we're going to need to change to get that OSPF neighborship to come up is under routing instances VPN-A. We won't need the RIP configuration anymore, so let's get rid of that. Okay, and now we're going to have a new IP address on the PE facing interface, and it's going to be an IPv6 address. So we'll do 1:2/127. Okay, let's take a look at the candidate configuration. Okay, so we've got the new IP address. We've still got it added to the VPN instance. So now we wanted to use OSPF version 3 to form that connection to the PE. So we'll need to do that under running instances VPNA. Okay, set protocols, OSPF 3, area 0000. Okay, and then we're going to do interface 0, like that. Yeah, so I think that's all that's going to be necessary. Let's commit that and make sure that the OSPF neighborship comes up. Oops, so it looks like I forgot to add some of the default information back in, so this command didn't make it. Oops, let's do set system root authentication. Go. Okay, and hopefully that other side is committed by now and the OSPF neighborship is in full. Okay, so we don't have a OSPF v3 neighbor yet. Okay, let's try the classic ping across the, oh, so oh, I see. Yeah, I don't need to specify the okay, so it looks like there's an issue with the configuration. We've got a direct route, but if I ping 1::2, the other side of the line, why does it say that there's no route to host? It should be using this route. No route to host. What? Why doesn't it have a route to host? Well, I mean, that's easy. Let's do show route 1::2. Okay, so there is no route to host. I think it's converting it to an IPv4 address somehow, or something strange is happening. Let's do INET 6 1::2. Still no route to host. How does that happen? Oh, you know what? It's because it's using this source address, I think. So let's do source. Still no route to host. Yeah, I don't know why this didn't work. Huh. So it's 0 connected to 1. Yep. Cabling's correct. Okay, well, what about the so the subnet, oh, you know what? This is the equivalent to a /31. So yeah, these aren't in the same subnet. I could use 0 and 1, or 1 and 2, or sorry, 0 and 1 or 2 and 3, but I cannot use 1 and 2 if I use the /27 because they're in different subnets. So I meant to use a /126. Alright, so let's fix that. Yeah, and you can use /31s, but for simplicity's sake, I'm going to use a equivalent of a /30. Okay, so now I'll have a route to the host because they're in the same subnet. So let's try to ping across the aisle now. Yeah, so I do have a route. It just looks like it's having trouble pinging. It's timing out for some reason. Maybe the other side isn't up yet, or there's, I need to know shut. Or, well, actually I'm not sure what's going on. Oh, there we go. Okay, it just took a while. We've got big delays. So yeah, everything looks good. I think I'll have a OSPF neighborship now. Whoops, still no neighbor, even though I can ping. Maybe it just takes a little bit of time. So we'll just keep that running, and then we'll look on the other side. Okay, so there's no route here, but that's because it belongs to a different routing instance. Okay, so yep, I can ping from there. Huh. Why can't I form a neighborship? Okay, let's get ahead of this configuration here. It's not going to fix my problem, but it's going to be necessary later. Okay, so I still don't have a neighborship, which is pretty kind of fascinating to me. Let's do some route options to see what's going on. So sorry, some trace options. Yeah, I don't think I need traffic engineering just for this connection. I would need it within the VPN, but not outside the VPN. Okay, it'd be nice if I could narrow it down to neighborship formation, but maybe packets, but let's just do it all for now. Okay, so oh, something happened. Oh, you know what? It might be because I don't have a router ID. Yeah, I think I need a IPv4 router ID in order for it to work. So it's going to be under routing options, I believe. Yeah. Okay, so we'll do 172.16.0.1. Okay, so I might need a router ID on this one too, so we'll use loop back here for that. Ah, here we go. Aha, so yep, you can't have a neighborship without a router ID. We should see a neighborship forming. Aha, so we received a hello now. So we should see something about a neighborship forming. Oh. Ah, neighbor change. So yep, I think we got it. Yep, everything looks good. So let's check that neighborship. Let's do a monitor stop, and then show OSPF3 neighbor. Perfect, we're in full. So, yeah, good old noggin from the previous exams. I was able to remember that you can't have you can't start up OSPF version 3 without a router ID, and the router ID has to be an IPv4 address. So it's kind of counterintuitive if you're configuring IPv6, but definitely not too hard to remember if you've done the prerequisite work to taking this test. Okay, so that's going to be all I have time for, I think. Let's take a final look at the configurations. So yeah, that's good. Let's take a look at the neighbor on this side, OSPF3 neighbor. So here's something that's interesting. It says that it's not running. That's because it's got to be specified for the custom instance. There we go. So you can make your default routing instance a L3 VPN, I think, but then your core links and stuff would need to go into a custom routing instance that's not a VPN. So yeah, that would just be nonsensical to configure it that way. Okay, so yeah, we're good to go. We've got that neighborship, so I'm just going to leave some notes for myself. We're going to say EBGP, VGC connection, and then we'll say static. Okay, so and then we'll remind myself OSPF. Okay, so this is finished, and next video I'll be finishing it here, and then I'll also have configuration required there. I'll be able to ping everything, and that will be that. I would like to take apart the full mesh and have it go to a route reflector at some point, and additionally use route confederations between point-to-point route confederations at some point as well. Let's take a quick look at the curriculum. Okay, so yeah, that would have been under BGP, so that's not going to be a part of this curriculum, so I might want to move on from that because I feel pretty confident that I can do it. And if I don't do one topic a day, so I've got I've got less than 30 days, and there are, I believe, quite a bit more than 30 topics, so I'm a little bit worried. A lot of it worried. Well, actually, there's not that much. It looks like there might be about 30 topics. So I do considerably less than one topic a day. I typically have been, but I might be able to keep that pace now, do one topic a day. If I can do that, then everything will be great. But unfortunately, today I didn't finish this topic completely. So I'm going to need to come back after work and make a video, and hopefully I can finish it then. So thanks for watching, and see you in the next one.